All right, you guys, we're going to continue our discussion on adding and subtracting radical expressions. So in the previous video, we added radical expressions that were like and that were unlike. Okay, so now we're going to move on to subtracting. Okay, so same rules apply to subtracting as they did for addition. So you can only subtract radicals if they are like. And remember, like means that they have the same radicand and the same index. Okay, so let me write that to remind ourselves. So if radicals are like, then their radicands are the same and their indexes are the same. Okay. All right, so let's look at this first problem that we've been given. So it says 5 on the square root of kp minus 7 square root of kp minus 4 square root of kp. So we're looking at their radicands first. So the radicand is the expression that sits underneath the radical symbol. So in the first one, it's kp, kp, kp. All of those are the same. Next, we're going to check to see if our indexes are the same. So on the first one, there's no number sitting on the hook. When there's no number there, it's understood to be 2. Same thing for the second one. Same thing for the third one. So we've established that these are like radicals, okay? Their radicands and their indexes are the same. So when we combine them, we're going to combine their coefficients in the front. So we're subtracting. So we have 5 minus 7. That's already negative 2. And negative 2 minus 4 is negative 6 on the square root of kp. All right, cool. All right, let's look at the second one. All right, so once again, we're looking to see first if we've been given like radicals, okay? So let's check their radicands. 5, 5, 5, we're good. Let's check our indexes. 3, 3, 3, we're good. So we're subtracting again, so we need to subtract the coefficients. So we have negative 2 minus 9, that's negative 11, and negative 11 and negative 13, that's negative 24 on the cube root of 5. Cool. All right, let's move on to the next one. All right, we have the square root of 72 minus the square root of 13. Okay, so for this one, all right, we can look at this problem and see that their radicands off the bat are not the same. Okay, so if their radicands are not the same, we're going to have to simplify these by reducing those numbers by primes. But let's check to see if the indexes are the same. No number there understood to be a 2. No number there understood to be a 2. So we have square roots, but we need to simplify. Alrighty. So let's break down 72 into primes. So 72 is the same thing as 2 times 36. 36 is the same thing as 2 times 18, 2 times 9, 3 times 3. Okay. Now, because the index on this radical was a 2, that means in order for these numbers to come out, they have to come out in pairs. Okay. So when we're looking at the 2's here, we have a pair of 2's here and a pair of 3's here. This 2 is alone, so it has to stay underneath. So when I go to write my answer, I'm going to multiply my pairs together. So I have 2 times 3, which is 6, on the square root of 2, because that 2 had to stay behind. All right. So let's work on the second one. All right, so we're going to see if we can break down 13. We can't. 13 is already prime, so there's nothing else we can do with that. We have to leave it alone. So minus square root of 13. Okay. So remember from the last video, we said even though you always have to simplify the radicals, sometimes they don't combine any farther than what you've been given, but you always simplify. Okay. Now, let me show you guys something really quickly. Let's change the color. All right, so when I broke down this square root of 72, okay, I broke it down all the way into primes just because that method always works, okay? Now, some of you guys are really good with your perfect squares and cubes and fourths, okay? So another way to think about breaking down that radical is there a perfect square that evenly divides into 72, okay? So I could have looked at it like this, square root of 72 2 times 36. Okay. If you know your perfect squares, you know that 36 is a perfect square. The square root of 36 is 6, and the 2 would have had to stay behind. Okay. So if you're good with your numbers like that and you easily recognize it, go ahead and do that. You don't have to continue to break it down into primes the way that I did. It's just some people don't easily recognize that, and breaking it down into primes always works. You pull out the groups and multiply them together. So just wanted to show you guys that.